Enterprise mainframes hold the core data that businesses rely on, but mobile and cloud developers build applications using standard RESTful APIs. When those cloud requests hit traditional mainframe architecture, they hit a barrier. IBM z/OS Connect Designer provides a bridge. It translates standard REST requests into native mainframe formats, allowing cloud applications to access z/OS data without requiring developers to write a single line of z/OS code. In this tutorial, we will set up a containerized workspace, import an OpenAPI contract, map the data visually, package the result, and configure system monitoring. By following these steps, you turn complex legacy integrations into a streamlined, low-code process. Step 1 requires two prerequisites: an active OCI-compliant container runtime, like Docker Desktop, and a completed OpenAPI 3.0 document. Before typing any commands, verify that your container runtime is actively running. A stopped runtime is the most common reason the setup fails. Open your terminal and pull the IBM zCon Designer image, then start it. Once the container is running, open your web browser and access the Designer Web UI via your assigned localhost port. Inside the Designer UI, upload your existing OpenAPI 3.0 contract. The tool accepts both JSON and YAML formats. This workflow relies on contract-first or top-down API creation. You provide the defined contract, and the system builds the implementation around it. Starting with an approved contract ensures the resulting mainframe API complies exactly with the standards your mobile and cloud teams are already using. Looking at the Designer Web UI, you can see how the tool automatically reads your imported contract and populates the API paths, assigning color-coded buttons for its TTT robes like GET and POST. Select an operation, for example a GET request, and open the Visual Mapping tool. This diagram illustrates the mapping process. On the left is your RESTful JSON request payload. On the right is your back-end native language structure, like a COBOL copybook. Using JSONata, you visually draw lines connecting the incoming JSON fields to their corresponding back-end fields. Take a moment here to verify your data types. While the designer handles the transformation routing, the logical data types between the JSON and the mainframe subsystem must align properly to avoid runtime errors. Because you visually connect these inputs and outputs, you eliminate the need to write or maintain any manual data transformation scripts. Now that your data is mapped, use the built-in testing tools to verify the connection. Once the test passes, export your project source files as a single .war file or web application archive. This flowchart details the deployment architecture. The IBM-zcon-designer container is strictly for your local building and testing. For production, your generated .war file moves through your DevOps pipeline and deploys directly into the IBM zcon server container. Packaging the API as a single portable .war file means it can be managed as a standard release artifact in any CI/CD pipeline. Once your API is running in the server container, you need to track its request times and system footprint using enterprise-grade diagnostic tools. IBM Z Omegamon for JVM provides real-time visibility into individual API requests. You can track status codes, monitor payload sizes, and measure elapsed response timings as traffic flows through the system. This dashboard displays metrics from the Java Health Center. It tracks the active JVM environment, ensuring your Java heap and thread usage remain stable, all while utilizing less than 3% of your CPU overhead. To maintain a historical record of system usage, utilize SMF records. Specifically, SMF 123 version 2 records log the exact entry and exit timestamps of every request moving through the z/OS Connect server. If you want to track specific CPU and ZIP processor usage with SMF 72 records, you must configure z/OS workload management classification first. Utilizing Omegamon, the Java Health Center, and SMF records ensures that your new API operates with complete transparency and minimal system impact. In just a few steps, we spun up a workspace, imported an OpenAPI contract, mapped to native structures, and exported a production-ready container. Mobile and cloud developers can now consume z/OS data natively via standard REST APIs, and system administrators retain strict oversight of system performance. Take your downloaded WAR file, integrate it into your automated CI/CD pipeline, and push your new API into staging.